Hey there, Dr. Royer. I'm looking forward to us meeting about your results of your EEG and maybe your sleep study. So we're going to talk through some of the initial data so that you can have this for your records, but also you'll have a scientific underpinning or foundation of what it is we're talking about. So when we're looking at your EEG, we're really looking at what it is that keeps you alive and allows you to function, which is the electrical current in your brain. Now, our entire body works off of electricity, not just our brain. Our heart, as you look at your pulse, is related, it's a muscle that needs that electric activity to pump and work. All of our muscles work off of electrical current. Our skin has electrical current over that. And the area that uses the most amount of electricity in our body is our brain, which is a 3.5 pound organ. And it needs this electricity 24/7. From the time you're born until the time you die, you have to have this electrical current running. Now, it may run in different speeds. Sometimes it goes slow, sometimes fast, but it's always on. And so that's very important for you to understand. It's also important for you to understand that where do we make this? Where does this electricity come from? We don't plug ourselves into the outlet at night, right? We're constantly this power plant that's making energy all the time that keeps the electricity going. So the first thing we typically think about, like where the energy comes from, is food, and food is important, but you can go days without food and still stay alive. So that's not the most important thing. Water is important, hydration definitely. Electrical current travels better through fluid, and so it's important to have hydration, but still not the most important thing. You can go a couple days without water and still function. Sleep is really important. I would put that at number 2 or 3 on my list of the most important things we need for electrical current. You go 7 days without sleep and your brain will start to lose touch with reality. And by day 13 or 14, you'll die and you won't be able to make the electrical current. But the single most important thing is oxygen. We need oxygen for the brain to work. And so you'll hear me talk a lot when we're trying to optimize the brain and body about oxygen production and why that's so important. It's estimated that 80 to 90% of the energy that we make comes from oxygen. Makes sense. How long can I go without oxygen? Just a few minutes. After a few minutes, I'd give up everything that I possess just to have one more breath of oxygen, and we need that to make energy. We'll talk more about that and other aspects of your feedback. But let's now talk about, once we make the energy, what is the next thing that we need to do? And that is, we need to manage the energy. So you have this really cool software system called the autonomic nervous system inside of you. And it's taking your senses and it's looking at the environment, and through your 5 senses, it decides how much energy you need to use at any given moment. So if there's a crisis, the autonomic nervous system figures that out through my senses, and it goes really, really fast. If it's at night and I need to sleep, my senses sense that there's no danger, and it slows down and the electrical current goes really, really slow. So we're constantly moving up and down this, but there is a certain aspect of the autonomic nervous system. If it gets out of balance and you're too far one way or too far another, that can dramatically affect your emotions, your behaviors, and your performance. So part of the EEG assessment, large part of that, is to get a measure of where you are on this autonomic nervous system. Depending on where we are on the autonomic nervous system, every system in our body gets impacted that. It either has a slow response or a fast response. Even my eyes, my pupils constrict when the autonomic nervous system goes slow. They dilate when they go fast. Heart increases, decreases. All these different things happen as we go in and out of the autonomic nervous system. So the purpose of the assessment is to really assess what the upstream brainwave activity is doing. And is it in too much of a sympathetic or crisis state, or is it in too much of a parasympathetic or a recovery problem state, or is it in this perfect balance? So we're going to go over your EEG, but before we do, I want to point out a few things on your EEG. So when we do the EEG, you either had one site or all three areas that we look at, center, left, and right. These principles apply no matter where we're looking at your brain. And that is that the EEG can show us how fast or slow the brain is going. And based on that, we can see the propensity for things that may be more crisis, inflamed, anxious based, or things that may be more slow, fatigue, energy based. So at the bottom here, you see an actual raw EEG. If you were just to kind of analyze that qualitatively, you'd see some things in there, but we're using the computer to break that down into all the different frequencies. The red line in the top diagram is the brain waves that are related to your ability to get into a slow state and kind of keep things in balance. If you have too much of this, then you're going too slow. If you have too little of this, then it's hard for your brain to recover, and that can be related to sleep. The blue line is referred to your high betas, which has to do with your stress responses. During the EEG, you don't need to know all of this, but I'm looking at all the different frequencies. There's 35 of these electrical signals going across that I'm analyzing, and they each do different things. Like the ones we're looking at here manage an individual's creativity. And then the one on this slide at the bottom manages stress levels. So once we have this data, we can start to analyze how balanced the brain is. So this is the graph that you're going to see. We've kind of taken all of that electrical current data and brought it down into two basic points. And this is really where I need you to have this information before we meet. Is your theta ratio is the slowing down of your nervous system. And that we don't want to get too low. We do not want the theta to get below 2, because that means the nervous system isn't slowing down enough, and it can be a precursor for cognitive issues. It gets too low, it can identify that maybe we're going to have some problems with memory because the brain isn't restoring itself at night. And so ideally we want this number to be right around 2.7. Now there's another thing that we don't want to have happen with this number, and that is to get too high. So think of it like a brake pedal. I don't want too little of a brake pedal, but I don't want too much. And so almost about 10 years ago, the FDA defined that if this number gets above a 3, that individual would have an attention problem. So we don't want to get above a 3. We don't want to get below 2. Ideally, 2.7 is great on this theta, okay? The other number that we're going to look at is your high beta, and this is the stress number. Unlike the theta, we want to go in one direction, and that's down. These are the sympathetic, fast brainwaves. We want those to always be in this ideal speed and to only use them when we're in crisis. If we're using them too much, this dot will start to get higher and higher on this chart. Okay, the ideal spot for this is to be below 0.4, below 0.4. If you fluctuate between 0.4 and 0.55-ish, that's okay. But if we start to get up into the 0.65s and higher, then we have way too much of the fast response in the brain. Hopefully some of this makes sense. Just remember theta ratio 2.7, we don't want it to get too high or too low. And high beta ratio, we want to get that always lower and lower, and below 0.4 is ideal. These electrical principles of how you function, how your brain functions, apply to all three areas that we're going to look at. So when we meet, we're going to be showing you these exact numbers, and now you have a greater context for where they come from and why they're important.